In a previous video, we were trying to figure out the equation of a line through 2 points. And basically what we needed to do was figure out what the slope was. So with these types of equations, where you're trying to create the equations of lines, they all are very similar. But it's all about, they're going to give you a coordinate on every single one of these. And whether they give you the slope, if they give you the slope, you can pretty much just kind of plug it right into your equation. If they don't, they give you enough information to find the slope. That's about the difference. And once you find that slope, then you just plug it into the equation. Okay, so the next version of this is trying to figure out the equation of a line if lines are parallel. So the only difference is they're just not outright telling you the slope. So just like on the other problems, you need to figure out what the slope is. So if you're talking about parallel lines, you're talking about lines that have the same slope. So what we need to figure out is the slope of this equation right there. Okay, so we need the slope. So let's figure out the slope. So the equation that whatever equation we're about to create needs to be parallel to this line. So it says, right, the equation of a line that is parallel to this, and it's going to pass through that particular point. And then write the new equation in slope-intercept form and standard form. Okay, so that's an extra step to this. Okay, so first thing is, let's create this equation. We need the slope out of this. So right now it's not quite ready to just pull the slope out of it, because the y is not totally by itself. So 3 is not the slope. What we have to do is divide the 2 on every single piece. And then now we have the slope. Okay, so this is our slope that we need. So rather than us finding the change in y over change in x, we're just going to steal that slope. And since they're parallel, the slopes have to be exactly the same. So that is the slope that we're going to use. So if our equation is going to be looking like this, what we just learned was the slope on this new equation is going to be the same as the slope on the other equation. So 3/2. But what we don't know still and always is the y-intercept. So that's where this point comes in. So that point is a sample that we can plug into here to figure out what the b needs to be. So our y value is 1, 3/2 of 2 plus a b value. So if we multiply this, we have 2 divided by 2, which is 1, times 3 is 3. So 1 equals 3 plus b. Subtract your 3 over to get b by itself. And so we have a -2 equals b. So our final equation is y equals 3/2 x minus 2. All right, so let's graph that. So if we graph that, that line would be of a y-intercept of -2. And also, by the way, it's supposed to pass through that point. So we'll come back to that in a second to really double check. So this graph has a y-intercept of -2, and then we would go up 1, 2, 3 over 2, up 1, 2, 3 over 2, 1, 2, 3 over 2. And then we could go backwards on it. So down 1, 2, 3, back 2, 1, 2, 3, back 2. Okay. And then, so that's our line. It should pass through this point, 2, 1. So 2, 1 is this, so that's perfect. And then the last thing that I want to double check is it should be parallel to this one. So if we graph that one, 1, 2, 3, 4, and go up 3 over 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Okay, so let's make a dotted line on that one. So that line is both parallel to this and it passes through that point. So we know we're good. So that takes care of the slope-intercept form. Standard form. The standard form, if you remember, looks like this. Equals C. All right, so the capital letters mean we should not have any fractions on this. So that's kind of step one. And then the other part is we're going to put the x's and the y's on the same side. So it's basically kind of going backwards-ish to this. This was almost in standard form. If we had that 3x over the other side, then we would have had standard form. So it's basically going backwards. Okay, so first thing I want to do on this equation is I want to clear out fractions. Okay, because a standard form is not supposed to have fractions, and the x and y's are supposed to be on the same side. Those are really the two things that we need to resolve. So the first thing is we have a 2. So I'm going to take that equation and I'm going to multiply every single piece by at least common denominator to clear out my fractions. So then I'm going to multiply the 3/2 x by 2. So I'm going to multiply that by 2. I'm going to multiply this piece by 2, and I'm going to multiply the 2 by 2. Okay, so that specifically is just to clear out our fractions. So this becomes 2y. The 2 divided by 2 is 1, times 3 is 3, and then minus 4. All right, almost standard form. We just got to pull the x over to the other side. Okay, so if we move that x over, we would have to subtract it to move it over. So that means it becomes a negative 3x on the other side. The y was positive, so we'll separate it with a plus. And that constant is a negative, so we'll leave it alone. And that is standard form. All right. Okay, so just a quick summary is all these types of problems except for the standard form part, but creating that equation is very, very similar. It's all about figuring out a slope. And then once you know a slope, use a point to plug it in to find out whatever you're missing, which is typically the y-intercept on this thing. Okay, so and the fact that they said that we needed something that was parallel just meant we were going to take that equation, figure out the slope for it, and then essentially just use that exact same slope because it's parallel. All right, thanks.